been, yeah, playing really well, so I'm happy about that.
Cool.
Yeah.
You been watching the Rockies?
Oh, I have 10-5 now. I haven't
They're
seen tonight's
unbelievable.
game. They're the first team to make it to 9 wins this season.
They are unbelievable.
So
They've got a
doing really well.
bullpen this year, and the bullpen seems to be making
Oh yeah. Oh yeah. Oh, they're gonna go. I don't know. I'm not gonna say it yet, but like they start off like this every year.
They play a lot.
Yep.
That's why
And they just go downhill.
I watch all my Rockies games early in the season because
Same, because that's
after about
where
30 games, they're out of it, and I stop watching.
I feel like they think they're doing so well that they can just kind of lay back a little bit, but you can't do that. You have to just stay on. Like you have to lots of energy, and
it's going to come down to pitching. I mean, their batting is always the same.
Yeah, for sure.
And they don't have that different of a lineup for hitters this year than last. But what is different is their pitching. And they seem like they have above average pitching. I saw a statistic the other day that was amazing. The Rockies have the fastest pitchers in the league.
I think I did hear that
Their
statistic.
fastball average is 94 point something. And,
which is extremely fast.
Well, and no other team was closer. The Mets and Nationals were both less, which is shocking that the Rockies are the fastest pitchers because they never generally have had that. So.
No, not at all. The Nationals are doing really well this year.
I've always been a fan of the Nationals ever since they got Steven Strasburg and
Bryce Harper and
it's hard not to root for the team that's got maybe the two best players in baseball. I don't know.
Oh, exactly. Did you know Bryce Harper was drafted right out of high school, first round draft pick, and he was the youngest player in the MLB to get drafted.
I lived in Las Vegas. I lived in Las Vegas when he was going to junior college.
Really?
Yeah. And he was hitting like 500 in every league that he was playing in.
He was, like home run every game. Just
it was
unbelievable power.
He did, yeah. And,
I mean, he had, like, when he was pitching, he was throwing 95. And then when he was catching, he had the quickest pop time of any catcher at that time. And then he also played shortstop and was unbelievable there.
Really? I didn't know any of that. I didn't know that he ever even tried pitching and stuff. Huh.
Yeah, and then he when he got drafted, he was their right fielder. So, I mean, you can go from playing middle infield to catching, you know. Like It's crazy how much they change it up.
He's impressive.
He is.
Steven Strasburg hasn't quite lived up to his original
standards yet.
His expectations. When he came out, they thought he was going to be the best pitcher that ever pitched.
Right. Well, they thought that about Jose Fernandez before he died.
I know. There's lots of pitchers that they've thought that, and they've all been wrong. So.
Yeah, for sure. I just think, like, with Jose Fernandez, like, I thought he was going to be one of the best pitchers of all time, and then I was in the middle of a game in Kansas when I found out he died, and it just hit everyone real hard because, like, I always watch, like, highlights of him and stuff like that. But it's crazy. It's crazy how quick your life can end, you know. Just gotta be smart about your decisions. He wasn't smart.
That's right.
He found high levels of alcohol and cocaine in his system. So.
That's right. How about Hernandez? Suicide.
Yeah.
This morning.
Jose Fernandez. Oh, Aaron Hernandez?
Aaron Hernandez, the one that was convicted of murder.
Oh, hung himself, didn't he?
He did, this morning.
Oh, man. He was a baseball player, wasn't he?
He was a football player, a tight end for the Patriots. He was kind of their star. He had a $40 million contract.
Wow.
Talk about throwing your life away.
Jeez.
He did it outright. He just took it and tossed it. And he had everything going for him. It's so hard to figure out people like that. How can you have a $40 million contract, be a star athlete, and decide
all away, and then kill someone?
Somebody and get caught and spend the rest of his life in prison. Yeah, I mean, that's like you said. It's all about choices and decisions, and he made some.
Exactly. I know. What was really sad was, you remember Joanna Ventura's death for the Kansas City Royals?
Yeah.
That was, yeah, like he was just driving in the Dominican Republic and this drunk driver hit him. Like it wasn't his fault at all. He didn't have any alcohol in him.
Yeah.
A guy swerved around the corner and just smashed into him, killing him.
Stuff like that happens.
Gosh, yeah.
That's
And then of course the drunk driver's fine, you know, like
right.
yeah, that's what really pissed me off. But you know,
Yeah.
well, that was my rant for the day. But
That's the way life is, I guess.
yeah, definitely.
All right. Looks like we are back on trig.
Yeah.
Okay. Finding angles that are coterminal is really easy.
Oh, okay.
If I want an angle that's coterminal to that, I add 360.
Oh, okay.
If I want another one, I add another 360. If I want another one, I add another 360.
Okay, cool.
With me?
Yeah, I got
Now,
you.
if I want a negative one, then I subtract 360.
Okay.
What do you get? You get minus 2, or excuse me, minus 170, I think.
Yeah.
Well, there's your negative angle. In other words, they want a positive and a negative.
Yeah.
There's the negative one, and the positive one was 130 plus 360. So 490 is a positive coterminal.
Okay.
Coterminal is the easiest thing in the world.
It is easy, yeah.
Multiples of 360. In other words, any angle that's a multiple, let's say I add 720 to that. Well, that's going to be coterminal. 850. Right. All your trig functions of 850 are going to be exactly the same value as all your trig functions of 130.
Okay. Cool.
So that's pretty much what coterminal means. Now, when they give you the angle in radians, then instead of adding 360 or subtracting 360, I'm going to add 2 pi, because 2 pi is the same as 360.
Okay.
Okay? So, what do I get if I add 2 pi to that?
Don't you find a common denominator?
Yep.
Okay. So we could use 8 for the common denominator.
Okay, keep going.
And then we would
2 pi in eighths.
So it'd be 5 pi plus 16 pi.
16 pi over 8. In other words, that is 2 pi right there. Okay, now what's 5 pi plus 16 pi?
21 pi.
That's the answer. 21 pi over 8.
Cool.
Great. Then you got to bring the denominator forth. Also. Okay, now if I want to find, that's a positive angle. If I want to find a negative angle, well, is all I have to do. That is in the unit circle. So if I subtract 2 pi, that's going to give me a negative angle. What's 5 pi over 8 minus 2 pi?
Minus 11 pi over 8.
Okay, back to degrees.
Sweet.
How do I find a positive angle for that?
For that, so you'd add 360.
There you
go. And then you would get, hold on, wait. 360, wait.
Minus 150 plus 360. What is that?
Yeah. So that'd be 240.
210.
Or 210, yeah.
It's really the same as 360 minus 150. And that's 210.
Okay.
Okay. So there's the positive angle, 210. Now how do I find a negative coterminal angle?
You'd subtract.
What is that equal to?
Minus 510.
Good.
Cool.
Your arithmetic skills are getting better.
Sorry, yeah.
No, they are. That's really important.
Mm-hmm.
Okay, so minus pi over 7, what am I going to do to that to find a coterminal angle?
Add 2 pi.
Okay, what's that
So
equal?
1. And then we would have 7 as a common denominator.
Okay.
So that would be minus pi plus 14 pi.
What's the answer?
And then you would get 13 pi over 7.
Oh, good. Very good. That's a positive angle.
Yep.
It's also inside the unit circle. In other words, it's less than 2 pi.
Uh-huh.
Okay, now let's find a negative angle.
Okay.
What am I going to do?
So you do minus pi over 7 minus 2 pi over 1.
Or 14 pi over 7.
Yeah.
In other words, I'm going to subtract 2 pi, right?
Uh-huh.
Okay, what do you get?
And then you get minus 15 pi over 7.
That's the answer. There's the negative answer. Now,
Cool.
granted, there are an infinite number of answers. In other words, I could subtract another 2 pi from that. I would still have a negative angle, and it would still be coterminal with minus pi over 7. Just like I could have kept adding 2 pi's. In other words, there's not just one answer. There are an infinite number of answers.
Okay.
Okay?
Makes sense.
Let's look at this.
Yeah, these aren't too bad.
These are all right triangles, and they tell you that C is the right angle. So it doesn't really matter whether I want to call that A and B or vice versa.
No.
Okay? Now, little a means the side opposite angle A, so that's 9. C, little c, means the side opposite big C.
Yep.
So immediately, can I solve for little b?
You can.
Okay, what is it?
Yeah, so you do 9 squared plus b squared is equal to 41 squared.
Okay, the easy way to get the short side is 41 squared minus 9 squared.
Oh, okay.
Always
you could do it the other way too, right?
Well, yeah, you could, but you got to do a lot more math. In other words, if you got a squared plus b squared equals c squared, well, now that means you got a squared plus 9 squared equals 41 squared, which means a squared equals 41 squared minus 9 squared, which means a equals the square root of 41 squared minus 9 squared.
Okay.
I encourage every student I have to do it in one step, not 4. In other words, if you have to go back to the Pythagorean theorem on every one of these right triangle problems, you're going to be doing 3 times as much work as you need to do.
Yeah.
Just remember that the short side of a right triangle, either short side, doesn't matter which one, is equal to the square root of the hypotenuse squared minus the other short side squared.
Okay.
That's all you have to remember in one step. Okay? And if you're solving for the hypotenuse, well, that's equal to the square root. All answers begin with square root of a squared plus b squared. So the hypotenuse is fairly easy to solve for. The more difficult one is solving for one of the short sides. But if you start with this formula at the bottom, you'll be a lot further ahead.
Okay.
Now tell me what the square root of 41 squared minus 9 squared is.
I got b squared is equal to 1600, or just 1600, and then b is equal to 40.
Okay. So if I plug in 40 for that, now we still have to solve the triangle. Solving a triangle means coming up with all 3 sides and all 3 angles. So I've got all three sides, and I got one angle. And I know that A and B are complementary, so if I can just solve for A or B, I'm in like Flint. Well, how do I solve for theta? Use any trig function you want. What's the sine of theta equal to?
That would be equal to 40 over 41.
Okay, how do you solve for theta?
You do sine
inverse.
Or just the reciprocal, yeah.
Not the reciprocal.
Or not the reciprocal.
Very important. It's not the reciprocal. The reciprocal of sine is 1 over cosecant. Mm-hmm. But the inverse of sine is inverse sine. In other words, if the sine of theta is equal to that fraction, then theta equals the inverse sine of that fraction.
Okay.
Now put that in your calculator and see what angle you get.
Okay, let me do that.
It's going to be a pretty big angle. It's going to be close to 90.
So you would do -1?
You got a TI-84?
No, TI-Inspire.
Okay. There's a trig key. Mm-hmm. Hit your trig key. Notice that it gives you 12 choices.
Yeah, yep.
Use inverse sine.
Oh, inverse sine. That's what I did wrong.
Uh-huh.
Okay.
I'll put in 40 over 41 as the argument.
Okay.
Now we'll convert that to an angle.
I got 77 degrees. Okay. 77.32.
So that's what theta is. 77.32. It says give lengths to the nearest hundredth and angles to the nearest tenth. So that's got to be 77.3 to the nearest tenth. Now what's A?
So if that's 77, that's 90.
Minus that.
Right.
Take 90 minus 77.3 and you get 12.7.
Exactly.
And now we've solved the triangle. So we had to use a combination of, since the only thing we knew were two sides, we had to use the Pythagorean to solve for the third side. And once you have all three sides, it's easy to solve for the angles.
Yeah.
You just always know this, Dylan. When you're solving for angles, you're using inverse trig functions. Here's the thing. We take trig functions of angles to get ratios. We take inverse trig functions of ratios in order to solve for angles. It's as simple and straightforward as that.
Okay.
Alright, now let's draw this triangle.
Yeah.
Again, C is always the right angle here. That's 10.
Yep.
And doesn't matter whether I call this B or A, but B is 18 degrees.
Yeah.
Now, what can you solve for? Right now I only have 3 pieces of information. That's all you ever need to solve a triangle, incidentally. It's 3 things. Either 2 angles and a side, or all 3 sides, or no, if you have all 3 angles you can't solve it. So all 3 angles don't allow you to solve it. The reason is that I can have a triangle like that, and I can have a triangle like that, and they both have the same 3 angles. But they're not the same triangle. This is a lot bigger one over here.
Right.
So 3 angles alone do not allow you to solve the triangle. But 3 pieces of information generally do. So what can I solve for? Let's call that little b. Let's call that little a, because they're opposite. Big A and big B. Well, what can you do? Can you solve for anything here?
Yeah, you can do sine, Sine. So you could do sine of 18 times 10.
Now, hold on. Sine of... Always, when you're doing these trig problems, always start your equation with the sine of an angle equals what?
Equals x over 10.
Not x, b.
Or b over 10, yeah.
So b, you were right. You were just 2 steps ahead of me. You got to be careful because I don't always see those 2 steps. So jump ahead of me like that. I don't know that you've done it.
Okay.
So put that in your calculator. What do you get?
Let me do that real fast. Sine of 18
round it to the nearest hundredth
times 10. 3.090.
3.090.
Yeah.
So that's 3.09. Now, what's the best way to solve? Actually, I know all 3 angles, right? What's angle A now?
Yeah, so you do, well, you could do 10 squared minus 3.09 is equal to...
easy way. First of all, what's angle A? Remember, A and B have to be complementary, right? It's a right triangle.
Right. So A would also have to be 3.09?
No, angle A. That angle right there.
Oh, okay. So that would have to be... Wait.
Angle A and angle B add to 90 degrees. They're complementary, always, with right triangles.
Okay.
So what do they
So 72. F 72.
All right. Now, we have all 3 angles, and we have 2 sides. We only have 1 side remaining to solve for. Let's use trig, not Pythagorean theorem. In other words, Pythagorean theorem would be okay, but that's a fractional decimal number, so I don't really want to square that, subtract it from 10 squared. Let's use a trig function to solve for A. What trig function will solve for A?
That will solve for A would be...
all kinds of them. Almost every trig function you could think of, you could use. Pick one. Pick one. What relates A and either 10 or 3.09? I actually prefer using 10 because it hasn't been rounded off.
You could use sine.
Not sine.
Right.
What relates A 10 degrees? Well, I guess you could use sine if you were going to use sine of 72. Okay. So give me the equation.
So sine of 72 is equal to A over 10.
Okay, so A is 10 times the sine of 72. Go ahead and come up with a number of that, and that's the answer. In other words, that is all I need to solve this. Rounded to the nearest hundredth.
Okay, hold on, so that was weird. My calculator just out. And then 72. 9.5.
Okay. It seems a little big because it's awfully close to 10. We know that 10 has to be the longest side of this triangle.
Yeah.
But the fact that this is a 72-degree angle means that this side A is going to be very close to the hypotenuse length. Because that's such a big angle.
For sure.
All right. Let's draw a picture for C.
Okay.
Again, once C is the right angle, then I don't care what I label A and what I label B. I'm going to get the correct triangle.
Okay.
So that's 7 degrees. That's a side of 18. Again, we have 3 pieces of information. We have 2 angles and we have 1 side. What's this angle B equal to?
Single B is equal to 18.
Angle A is 7. What's angle B?
Oh, 90 minus 7, so 83. Okay. Cool.
Now I got all three angles and one side. So all I have to do is find some trig functions to solve for little a and little c. Give them to me.
So we could do...
Notice what you can't do. You would not be able to say cosine of 83. In other words, I can certainly say the cosine of 83 equals a over c, but that doesn't allow me to solve for anything. Because I got two variables there. I don't know what they are.
Could you use sine? So
you have to use a trig function that uses one of the numbers and only one variable. Yeah, you could use sine. So give
sine of 18 times the sine of 83.
Give me the... I hate it when you skip a step like that, Dylan. Because I just don't like it. I can't even explain why. It's because to understand these, you always want to start out with the trig function. You don't want to start out with 18 times sine. You want to start out with what is the sine of 83 degrees equal
to? Is equal to, so 18 over c.
Notice that means that c equals 18 divided by the sine of 83 degrees.
You're right.
So jumping two steps in one there would have gotten you the wrong answer. So what is 18 divided by the sine of 83 degrees?
Let's see. 18.135.
So
18.13.
14. If the next digit is 5, it rounds up.
Right.
Okay. So now we got two sides. How can I solve for A?
18.14 squared minus 18 squared.
Don't use the Pythagorean theorem. Here's the reason I don't want you to use the Pythagorean theorem. It's because we rounded that off. So if we use the Pythagorean theorem, we're just going to add to the round-off error.
Okay.
I don't need to use any round-off error at all. I can relate 18 and A by what trig function? Both of those are perfect numbers. In other words, nothing's been rounded off yet. So what relates 18 and A?
Tangent.
Of?
So it'd be tan of 7 is equal to A over 18.
Good. That's the good way to do it. That means A is equal to 18 times the tan of 7. In other words, leaving your variable in the numerator was smart. As opposed to, I could have said the tan of 83 degrees is 18 divided by A. But then A is in the denominator and I got to do a lot more arithmetic. This is one step. So all you need is that number, and you've solved this triangle.
Cool.
Go ahead and get that if you want, if you need an answer for it.
Oh yeah, let me do that. And then it was tangent of 7? Yeah.
Yeah. Equals
2.21.
Okay.
Cool.
Now, let's real quickly, let me show you how to do the next 8 problems.
Sure.
What is the conversion factor when going from degrees to radians?
I'm not sure.
Well, it's either 180 over pi or it's pi over 180. Which one?
Pi over 180.
Correct, because we want to lose the degrees, right? In other words, that means the degrees will cancel, and I'll be left with radians.
And then when we want to lose the radians, we do 180 over pi.
Exactly. So this conversion factor is also pi over 180. So is this one. I'll let you do the math yourself.
Okay.
Negative numbers don't matter. It's going to be a negative answer.
Right.
Now, when I'm converting radians to degrees, what is my conversion factor?
180 over pi.
Notice the pi's always cancel.
Exactly.
That becomes 45, so the answer is 17 times 45. But yeah, these are all 180 over pi.
Cool. That's easy.
Yeah, very easy. These problems here is just a question of knowing whether it's 180 over pi or pi over 180.
Mm-hmm.
You can always figure that out as to what you're trying to lose. In other words, when I'm converting from degrees to radians, I'm trying to lose the degrees.
Right.
And gain radians. And same thing when I'm going from radians to degrees, I'm trying to lose the radians. Well, that's radians, so is that. So radians cancel and I end up with degrees.
Okay.
So 9 and 10 are really quite easy.
Cool.
And real quick, let me just show you how to set up 11.
Sure.
I won't solve it because we're at the end of our time. But these problems are always triangle problems, especially flagpoles. Draw the flagpole. You're standing 35 feet from the flagpole. That's a right angle. Flagpoles are always right angles with the ground. There's our triangle. The angle of elevation to the top of the flagpole is 30 degrees. That's what they mean by that.
Gotcha.
Okay. Now, I got 3 pieces of information. I got 2 angles, and I got 1 side. Well, I know that angle's 60. What's the height of the flagpole? Give me the trig function that's going to let me calculate the height of the flagpole. Solve for y.
Okay. So let me see.
Got to do something that relates y, and the only side I know, that 35.
Right. So you use tangent.
Give me the equation.
So tan of 30 is equal to y over 35.
You got it.
Cool.
That allows you to solve for y, and that's what they want. What's the height of the flagpole?
Sweet.
To the nearest tenth in this case, which is unique because the others were to the nearest hundredth.
Right.
All right, Dylan.
Cool.
Yeah, you're pretty good with trig. Yeah,
I feel pretty confident about it.
They do a little bit of trig every year. They give you a little bit in, I don't know how much they gave you in Algebra 1, but you got a little bit in geometry.
Yeah.
A little bit more in Algebra 2. And then next year, if you take trig, you'll get the rest of it. And anyway. All right.
Cool.
Well,
all right.
Week. I'll talk to you next Monday.
Sounds good. Thanks, Mr. Cowan.
All right, Dylan. Bye-bye.
All right. Bye-bye.